Solve one problem on model 11, which is deterministic model. Given question is, a company manufacturing cold drinks uses a capping machine which caps bottles at the rate of 1 every 2 seconds. The bottles arrive at the rate of 1 bottle every 4 seconds. If in the beginning there are 20 bottles to be capped, how much time is required to service the bottles that are waiting? This question was asked PTU B.Tech C.Sc 2009.
We will solve one problem related to queuing model 11, which is symbolically represented as DD1 FCFS infinity, in which there is deterministic or constant arrival rate, deterministic or constant service rate, number of servers provided is 1, service discipline is on the basis of first come first serve, number of units allowed into the system infinity, and population or calling source is also infinity. We can say that inter-arrival time and service time is fixed. So for this inter-arrival time and service time, we will consider here letter A and B. So inter-arrival time A is given in the problem 4 seconds, and service time, that is B, is equal to 2 seconds. It is also mentioned that in the beginning there are 20 bottles to be capped. That is, there is already is queue having 20 bottles before the service is getting started. Now if we compare this A and B, then this service time is less than A. That what will happen after serving certain units, queue will disappear. So we have to find out those number of units after which queue will disappear, because service time is less than inter-arrival time. So here we have not calculated arrival rate or service rate, but we have to consider service time and inter-arrival time, because we have to compare these times, because these times are fixed and deterministic, or we can say constant. So B is less than A. Now we will calculate the number of units that are served before the queue will disappear. So initial queue will diminish as service proceeds. So at certain point queue will diminish, because service time is less than the inter-arrival time. So how to find out that number? So number of waiting bottles, that is LQ, which is equal to NA minus B divided by A minus B, where N initially there are 20 bottles. So we can say that N is equal to 20. So this N multiplied by A, because inter-arrival time is 4 seconds. So NA minus B divided by A minus B, that is 20 into 4 minus 2 divided by 4 minus 2, which is equal to 78 by 2, which is equal to 39. So 39 units will be served before the queue will diminish. So after serving 39 bottles, queue will diminish or disappear, because service time is less than inter-arrival time. So what is the time required to serve these numbers of bottles? So how to calculate time? Time required to service waiting bottles, that is this number multiplied by this service time. So if we multiply this with 2 seconds, then your answer is 78 seconds, because time is given in seconds. So answer, that is time, is also having the same unit, that is second.